speed it up a little. Okay, turn the toolpath off. So here is our finished part. We have our outside roughed, our outside finished. We have our O-ring groove roughed and finished. We have the front facing finished. And for the inside, we have 3 drilling operations, one for starting drill operation, and then one to rough out this diameter here, another one to rough out this diameter here. And then we did a roughing in this section right here. And then we did a finishing all along the inner diameter. So now what we have to do is the threading. So let's talk about threading. So let's go in here and talk about this a second. For any threading, we support straight threads or tapered threads. On this part, obviously, it's going to be an external thread, and it needs to be a 2.5 inch -8 threads per inch NPT, National Pipe thread. It's going to be an external tapered thread. So what's important to know about threading is this profile needs to be exactly represent the outer major diameter of the external thread. So just look up your thread online or go to your threading specs and look up what thread you have to cut. Look at the major diameter. Okay, so you need to make sure you match that major diameter and you match the taper for external threads, which is 1 degree 47 seconds, I believe. So this portion that's going to thread from this endpoint to this endpoint, that line has to be the major diameter, okay? And it has to be at the right tapered angle, okay? So that's one thing to note, very important for threading. So let's go up here and we're going to pick threading. We're going to pick our threading insert. Just 1 second. For the thread parameters, okay, we're going to pick the point. Let's look at these parameters here. So these are our start and the end points. We're going to pick them here in just a second. But you also have an X clearance and a Z clearance, okay? And here is our thread pitch. It's a 0.125 pitch from point to point to point. So there's going to be 8 threads per inch, and they're going to be 1/8 of an inch apart at the bottom or the top, however you want to calculate it. And it's going to be a right-hand thread, and the depth of this thread is 0.1. So these parameters, again, look up your threading specs and make sure these are set correctly to match the type of thread and size of thread that you want to cut. Very, very important that these are set correctly. And this point here, we're going to go ahead and pick. We have our endpoint set. And if you recall, we put a point right there. So it snaps to that endpoint. And then we're going to stop. And what we did here is we calculated the theoretical point of the taper in the front, and we put a point there so we can select it accurately. So we're going to pick that for the endpoint. Okay. So here is our dimensions for the thread, or the extents of the thread. So for advanced cut parameters, some arc fitting, clearance, set to automatic. This is set to skim. I don't think we need to skim. I think we can set that to clearance. Thread cut parameters. So here's another important dialog. So for the first pass, it's going to be set to 40 thousandths and number of spring passes. So a spring pass, if you think of a thread, is actually a spring. So it's a helical motion from one end to the other. So it's a spring. So we're going to do 2 finishing passes, okay, from left to right, okay. So it's going to rough it out to 40 thousandths, and then it's going to do 2, one roughing spring pass and another finishing spring pass. Now, the way we do threading, you're not going to actually see it until you simulate it, okay? But the actual tool pass will just show you what they look like here. So for the G-code type, so our threading relies on the internal cycles of your 2.5 axis lathe. So we're not doing a point-to-point-to-point thread. We're actually using the G codes that are built in to your controller. So the most common thread type is a G76, and we're going to be using that because our FANUC controller has a built-in G76 thread. It's like a thread wizard. All of the information needed to cut that thread is all out on one line of G code, and we're going to show you that when we post it out. But you could use these other options. A double block means that it's going to be using 2 lines of G code, okay? Probably for finishing, roughing and finishing. And then a single block, think of a single block being how many passes. So it's a block, if you think of a square block, it's going to be coming in, doing 1, retract back. You see that square block I'm drawing? So that is a single block. So it's going to be finishing all in one block, roughing and finishing all in one block. And that uses a G32 or a G33 code. Or again, you can use the box cycle or G92. Again, the box, meaning there's going to be one pass using the G92. If you need more information on these G codes, you can look them up online, use your AI tool, and it'll give you all the information you need to understand how these G codes cut thread. So for the in-feed type, we're just going to use the constant volume, okay? And for the minimum cut, we'll leave it set to 0. The pull out has to do with how it's going to be cutting out on the end. We already have a chamfer. If you had like a square corner, you could use this pull out and it'll actually cut a small chamfer on the end for you. But we did give it a pull out value and a finish allowance of 2 thousandths. So when we do the finishing pass, there's going to be 2 thousandths left on the part. Again, for our clearance, let's check that. Let's generate that. Let's turn that on. So you'll see what we show here is just the linear passes of the insert down to its depth. So we do a rough pass, and then we do a number of rough passes, and then we do a finishing pass on the bottom of the thread. So let's go ahead and simulate that. Okay, went a little bit fast. If you want to go slower, we can change this. See how that slows it down? Okay, so it's not going to slow it down. Let's take a look at the thread. Okay, so it did an external. This is the 2.5 inch -8. So there's 8 threads per inch. Okay, and it's on a taper. If you wanted to do a straight thread, the same rules apply. Make sure that you have this portion of your drawing to the exact major diameter of the external thread. Okay, and here is where you check this box if you want to have a straight thread. So if we check that and generate, you'll see that it just made a straight thread. Okay, let's go ahead and set that back. Okay, so it looks like that is the last up. No, we do a parting off. So now everything's done on the inside. We're going to part it off on the back. Let's go to turning, parting off. 1 second. So we're going to use our parting off tool. And for our part off position, this value here tells it to go all the way to the center point. So make sure it cuts it all the way through. If you didn't want it to go all the way through, you could adjust this. And we're just going to pick this back point here. That's why we put that point there. Set the end point. Okay. So the right, I guess you could say the right edge of the part off tool is going to cut right on this point. Okay, so we're not going to do multiple passes. And let's see what the entry and exit looks. I believe that can just be the default values. So, okay, it looks like we're an error there. Okay, it looks like it froze up on me on the threading. Let's go ahead and go over, I mean, on the part off. Let's go ahead and drag this over and I'll show you what it looks like on this one. Not sure why I did that on that one. So here's our parting off. So here's parting off the right side of the part off tool at this back point. Let's go over here and rotate this around so we can see it. And we'll simulate this. Looks like we got it right to the end, Joe. Any questions?
Actually, there was a question on the machine setup. Do you just want to talk about the machine dialog? Yeah.
Yeah, so basically you're entering what your travel limits are, and your machine manufacturer in the manual, it'll tell you what those are, and just make sure you match those limits. And during simulation, if you pass those limits, okay, you can get it to flag for you. If we go, there's a checkbox here to stop simulation on error. So if there's any reason your insert or your toolpath violates the machine limits, it'll stop and it'll warn you. So that's a good thing to know. Just make sure these are set up accordingly. And you also have a tool change point set to 10 in the X, okay? Anything
that
else?
tool change point that tool change point can be used in the post processor. It's typically not really used in the toolpath generation itself, but it can be sent over to the post, and the post can be modified to use it.
Yeah, right.
Last part, posting. Posting was the other question.
Yep.
Do you want
Okay, let's go ahead and simulate this real quick, then we'll do posting. We're gonna just do it from the start. There's our OD roughing, OD finishing, roughing. There's our finishing passes on the outside. There's our groove, our starter hole, our roughing hole, and a roughing hole, a roughing, and then finishing, and there's our threads and the parting off. Okay, let's look at the post. So we have the post set to FANUC. No, looks like we didn't have it set to FANUC. Let's go down here. I have a post. I have a post here. So I have a FANUC AMS webinar post. And again, we have many FANUC posts in our list here. The default folder where the posts are in your product, I just changed the default folder to my working folder. But you have a whole list of posts. I think there's like 10 or 20 FANUC posts in there, Joe. Correct me if I'm wrong. Most popular 2.5 axis turning post. Okay, so we got that set. We're going to go ahead and post this. So here is our G code, and it's got all of the operations listed from start to finished, but a particular note. Let's look to see if we can find our G76. So here is our G76. That's our thread, one line of code for the entire thread, okay? And pretty much, I believe that pretty much any turning 2.5 axis turning center and controller that you have will probably support a G76, which is the most popular threading operation in there. Any questions on posting, Joe?
No, I think that's it. I think we're pretty much done with it, right, Don?
Yep.
Okay, all right. Thank you all for attending, and we'll send out the cleaned up video once we get a chance to do it, and then we'll see you next month for our next webinar.
Also, I wanted to mention that we are having a blog post on turn threading that will be coming out soon, probably in the next week or so. So keep an eye out for that as well. Goes into a lot more detail. Thank you, everyone.
Take care. Bye-bye.
Bye.